Okay, moments. Moments are turning forces. That's all they are. They're forces around a pivot. A pivot is something that something else can turn around. That's all. So in this case, it's a seesaw. Look, seesaw, 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 seesaw. The whole seesaw, the whole plank, is pivoting around the pivot. So if I pull it down, it goes back again. Not rocket science yet. Okay, if I plonk a weight, some kind of force on the seesaw, in this case a fire extinguisher, ka-ching, doing, the force of the fire extinguisher turns the seesaw. Now, it's important to understand that what's happening to the seesaw is it's pivoting around the pivot. See? Turning around the pivot. If I want to turn it the other way, I have to apply a force. Now, as you have worked out, the amount of force I have to apply to overcome the force of the fire extinguisher depends on where I apply the force. If I take the end of the seesaw, imagine you've got a particularly fat friend there. I'm sure you've got one of those. A particularly fat friend is shaped a bit like a fire extinguisher at the end of a seesaw, and you've got to pull him or her or it up into the air. Well, think of it as a sort of recalcitrant fat child that you're occupying for the afternoon in the park. Now, if you want to get this child in the air, if you grasp the end, the other end of the seesaw and pull down, go, assuming the seesaw doesn't break, you've applied a force and you've applied a moment in the opposite direction. So the fat child fire extinguisher is applying a moment in this direction. That moment is in the clockwise direction. You are clockwise because if you start at 12 here, it's going 1, 2, 3, 4, 5, way around. That's clockwise, clockwise, clockwise. If you want to counteract that clockwise moment, you have to apply an anti-clockwise moment. And by applying an anti-clockwise moment, you counteract the clockwise moment. Anyway, if you want to move the fat child up into the air, oh, hang on, there we are, and you catch hold of the seesaw about there, it's a lot harder. That's me straining because it's a lot more difficult. I have to apply a lot more force if I'm close to the pivot. If I'm next to the pivot here, it's almost impossible. Try opening your front door by pressing right next to the hinge, right next to the pivot. You have to apply an awful lot more force. Over here, really easy, fat child in air. I'm going to see if I can catapult the fire extinguisher. Oh, no. It appears the simulation doesn't run like that. Anyway, I can apply a clockwise moment, an anti-clockwise moment to completely counteract the clockwise moment by putting a similarly shaped fire extinguisher type fat child on the other side of the seesaw. Doing. Okay, the seesaw now returns to a level situation. There we are, arrows, level, level. Because the forces are equal, not only are they equal and acting in opposite directions, but they're also at the same distance. Right, if I move this right hand moment, oh look, if I put the child back here, not as much clockwise moment. Why is that? Because the anti-clockwise moment is at 1, 2, oh, hang on, put rulers on here, there we go, there you go. The anti-clockwise moment is at 2 meters and the clockwise moment is at 1.5 meters. So if I move this to 1.5 meters, we have the same moment on each side. We have the same moment. This one a clockwise moment, trying to turn it this way. This one an anti-clockwise moment, trying to turn it this way. Seesaw is level. Move this one in. Not level. So far, not rocket science, okay? A moment then, simply, let's just turn this off because it's confusing. A moment then simply is a turning force around a pivot, and it has two components. It has a force, in this case it's just giving it a mass of 5 kilograms, which of course you will know is a force of 50 newtons. If you don't know, ask me why. Okay, it's because 5 kilograms in Earth's gravity, which is what? That's right, 10 gravities. One gravity is 10 Newton meters. Sorry, 10 newtons per meter. 10 newtons per kilogram. We have 5 kilograms here, so therefore 5 times 10 is 50 newtons. The force of this fat fire extinguisher child is 10 newtons. Sorry, it's 50 newtons. And it's 50 newtons in that direction. And this 50 newtons is acting at 1.5 meters. So the moment is 50 multiplied by 1.5, which I think you'll find is 75 Newton meters. That's the unit of moments, Newton meters, newtons time meters. As long as we've got the same 50 newtons multiplied by 1.5 meters on this side, we've got a balanced seesaw. We have the same turning force around the pivot in both directions. Now, all as they try and do with this is ask you interesting questions like, okay, if I put 2 fat children on this side, one at 1.5, one at 2, where do I put the ultra-fat dustbin-shaped human? Do you want to work that out? No, let's do it by trial and error then. Okay, we've got 10 kilograms, which in Earth's gravity is how many newtons? Remember, Earth's gravity? 10. 10 times 10? That's right. 100 newtons. So we got 100 newtons at 1.25 there. It's clearly not enough, is it? Because the clockwise moments, the ones turning it this way, are more than the anti-clockwise moments, the ones turning it this way. So I have to either increase the force by picking it up and there we go, or I move the force further out. So if I move the force to here, I get, wait for the levels guys, ching. We just check that mathematically. How many newtons? That's right, 100, yes, well done. It's 100 newtons times by 1.75, so 1.75 times 100 is, sorry? Yes, 175. So we've got 175 Newton meters turning it anti-clockwise, which means because it's level, the sum total of each of the 2 moments on here has to add up to 175. So let's work it out. 5 kilograms is how many newtons? That's right, 50. So 50 times 2 is 100. So I'm willing to bet that this should add up to 75 to balance that. So we got 50 times 1.5. 50 times 1.5 is 75. So in total, the clockwise moments 175, and here in total the anti-clockwise moments 175. Just turn the level off. Does that make sense? Don't know how else to say it other than to put all of the things on this side and see if it breaks. Alas, it doesn't. Okay, if you're still confused, ask me, and we'll do something else. Bye bye. How do you turn this off now? Hello? Hello, want to turn off? Oh dear, won't turn off. It's rather embarrassing. I just have to keep talking. Seriously. Seriously, guys. Ooh! What's happening? Ooh! What's happening? Oh, hang on, it's a little button.